Hey students, this is lesson 731. We're going to learn how to solve systems of equations. And this little problem will kind of get you introduced to that. Farmer Melvin has a farm with chickens and cows. He took a recent head count and found there were 81 animal heads. Find 3 possible combinations of chickens and cows he might have on his farm. So if there's 81 chickens and cows, or 81 heads, then that should be the same as the number of chickens and cows. So some possibilities would be like 1 chicken, 80 cows, or 40 chickens, 41 cows, 60 chickens, 21 cows, etc. And you're probably getting the idea that there are many possibilities here, and there are. And the way you would check to make sure you have the right answers, you would make sure that your chicken heads plus your cow heads add up to 81. So if x is the number of chickens and y is the number of cows, what equation represents the number of animal heads on his farm? Well, as you can see from those examples, we just added the number of chickens plus the number of cows to get the total number of heads, which is 81, so that equation would represent that. And you might also notice that that's a linear equation in standard form. All right, the next question says Farmer Melvin's wife Eleanor counted the animal legs and found there were 252. Find 3 possible combinations of chickens and cows that would have 252 legs. So again, let's make a little table here. So we have chickens and cows. And now we're going to make sure that our number of chickens and cows have 252 legs. And so we have to think that all of our chickens have 2 legs and all of our cows have 4 legs. So let's just say, for instance, maybe we have 100 chickens. That means we have 100 times 2 legs on those chickens, which is 200, which leaves me 52 legs left for my cows. So I'm going to do that 52 divided by 4, and I'm going to find that I have 13 cows. And just to check that, I would do 100 times 2 plus 13 times 4, and that has to equal 252. Well, some other possibilities you could have for that are you could have 124 chickens. That would be 248 legs. That would leave you 4 legs for cows, which would give you 1 cow. You could also have 86 chickens and 20 cows. So if x is the number of chickens, and y is the number of cows, what equation represents the number of animal legs on his farm? That would be, so we want to take the number of chickens, x, times 2, plus the number of cows, y, times 4, and that has to equal 252. That is, again, a standard form linear equation. And that can represent all the possibilities of chickens and cows that would have 252 legs. All right, now if we put those 2 equations together, we actually can find the number of chickens and cows Melvin and Eleanor have, because we have 2 equations with 2 variables, and there's actually 1 solution for this set of 2 equations. In other words, there's 1 number of chickens and cows that both have 81 heads and have 252 legs. I'm going to leave that up to you to figure out how many there are, and hopefully that'll intrigue you enough to want to know, is there an easy way to solve a system of equations like this? And that's what we're going to do in this lesson. We're going to learn how to solve systems of equations. All right, I'm going to skip now to just show you how to do a couple problems, and we'll come back and do these other problems in class here. So I'm just going to give you a couple examples. I'm going to do the first couple homework problems here. One way we can solve a system of equations is by graphing. And if you think about a line, graphing a line, this line will have a certain look to it, a certain slant given by its slope, and so will this. And what we're looking for is a value of x and y that will be true for both of those. And just think about this. Let's graph this. So my y-intercept for the first equation is 3. My slope is -1, so that means I'm dropping 1 every time I go over 1. So that's going to look like that. And I'll go ahead and draw a line through that. All right, so there's that equation. And my other equation has a slope of -1, or a y-intercept of -1 and a slope of 1. So that's this. And what hopefully is intriguing you here a little bit is that these two lines meet at a certain point. And remember that a line represents all of the solutions for a certain equation. So this line here represents all of the solutions for this equation. This line here represents all of the solutions for this equation. And the place where they cross, that one spot right there, the black dot there, that represents the solutions to both of these equations. I'm going to write that point down. That is 2, 1. And if I put 2 in for x and 1 in for y in the first equation, so substitute those values in, I get that, and you'll notice that 1 is equal to -2 plus 3. And if I do the same thing for the second equation, so I put 1 in for y and 2 in for x, you'll notice 1 is equal to 2 minus 1. Well, that is the one spot when x is 2 and y is equal to 1 that there's a common solution to both of those equations. All right? So one way we can solve them is by graphing. And there's an example for you. I think I'll do one more example here. All right, so let's do number 5 together. Let's graph y equals 3x minus 4. So I'm going to put -4 right there on the y-axis. So the y-intercept is -4, the slope is 3. That means every time I go up over 1, I go up 3. So there's that line. Go ahead and draw a line through there. That looks like that. And then the other one has a y-intercept of +3 and a slope of -1/2. That means I'm going down 1 for every 2 I go over. That would look like that. And hopefully you notice that these two lines are crossing at the point 2, 2, right there. So that's the solution. And I can write my solution as an ordered pair, but I have to remember that what I'm saying is the common solution to both these equations is x equals 2 and y equals 2. In other words, if I substitute those values in for the equation, so y is 2, if I do 3 times 2 minus 4, those are equal. And if I do y equals -1/2 times 2 plus 3, those are also equal. All right? I'm going to show you one more other way to solve one of these systems. I'm going to do this one on, I think I'll do this one right here. I'm going to use the calculator to do that. So I'm going to turn on the calculator here. All right, so I put those two equations in my calculator, and you can see that. I remember that was a fraction, -1/2, and I just put it in as the decimal point 5, which is 5. Okay, and now I'm going to use my standard window, and hopefully you will see it on there. And we want to see the place where they cross, and we can see that right here. There's the point. It looks like the point is 1, 3. Now, there's a couple ways I could check it. I could check it on my table. And if on my table I go to 1 and notice that at 1 the two y values are different here. That means that isn't the right solution. But notice at 2, we have the y values are the same. That represents the solution to this equation, because we have the same y value for a certain x value. All right? And then one other way you could solve this is by pressing the trace button and then just trying to find that spot where they cross there. And if you just use the trace button, it'll just estimate. You'll notice that my x values here aren't, and y value aren't exactly 2, 3. But if I press second trace, and then number 5 intersect, and then I just press enter 3 times, the calculator will actually do a little bit better job of estimating where that point of intersection is. And we can see that x is 2 and y is 3. So my solution to this system is x equals 2, y equals 3. And that's this point right here. We also should make sure we fairly accurately graph that, and you can use your graphing calculator to help you estimate where the graph is also. But we can quickly put that in. There's one of the lines, and the other line had a y-intercept of 4 and a slope of -1/2, so that would go through there. And that's how you solve a system of equations, by graphing. All right, I think I'm going to end the lesson here, and we'll do the rest in class. I'll see you tomorrow.